My name is Landy, and today I wanted to talk to you about subnet masks. If you've ever had to set an IP address on a computer, you're probably familiar with having to set an IP address, a subnet mask, and a default gateway. And I feel like most people probably understand what an IP address and a default gateway are, but a subnet mask is a mystery. I know to me it was for years, and it was just some magic numbers you had to put in that I didn't know what they meant. And if you put the wrong ones in, it didn't work, and it didn't make any sense. So today I want to clear that up. So let's take this example network here. We've got a bunch of servers connected to a switch, which are connected to a router. And then we've got another switch with some PCs connected. Now, most IT professionals are going to be familiar with IP addresses and setting IP addresses on different servers and workstations. But networks don't actually use IP addresses in the local level. It's Ethernet. It's all layer 2, so we actually use MAC addresses. So whenever you want to send a packet from one IP address to another, your computer actually looks up the destination MAC address for that IP address and forwards the packet over Ethernet for that MAC address. Now, if it's local, you're going to go from one machine on the same network as the other machine. It's going to just look up that MAC address directly, and it's going to forward that packet directly from one server to the other. It's not going to go across the router at all. It's just going to go straight across the switch direct. If it's on a different network, the computer will look up the MAC address of the router or the default gateway, as it was in the configuration earlier. And it's going to forward that packet to the router's MAC address, and then the router will be responsible for forwarding it on, maybe directly if it's connected directly, or if it's connected to another router. It may take several hops, but it's actually going to be going MAC address to MAC address along the way. But the question is, how do we know if it's a local or a remote address? What makes an IP address local to the subnet? The answer is masks. So IP address is actually made up of two parts. You've got the network portion of the address, and you have the host portion of the address. Devices or computers that are on the same network, they have the same network part of the address, are local. So you know 57 is your local host. You want to send it to 58, but all the other parts of the first part there, the network address is all the same. Same network. Forward directly based on MAC address. So I've written this out in binary because it makes this make a lot more sense to me, and I hope it helps you. So the first thing I've done is I've written the IP address out in binary, and I've added spaces and dots just to make it easier to read. But you don't need those. You can actually just jam all those bits together, and that's still the same IP address. And it's just a series of ones and zeros. We've got our decimal number converted to binary here. The subnet mask on the second line is the one that people are probably most familiar with, is 255.255.255.0. You'll notice that in binary, that is a series of ones, all as a block on the left side, and then a series of zeros, all on the right side. And that's how a subnet mask works. That's why you get these weird numbers like 248 or 255 or 128 or something. They seem arbitrary in decimal, but whenever you put them in binary, you can see it's all just a series of ones. And so we actually use this where the ones on the left side are the network part of the address, and the zeros on the right side represent the host part or the local part of the address. So we actually, to figure out the network address, we actually apply a bitwise AND operation. And if you don't know how that works, the truth table of it is if you have two ones as an input, the output is also a 1. But if you have a 0 in there anywhere, the output is a 0. So 1 and 1 is 1. But 1 and 0 is 0, or 0 and 1 is 0, or 0 and 0 is 0. So that's the whole truth table. But you just apply it as a mask. It's a binary mask. If you look a little bit deeper, that's why it's called a subnet mask. We're masking the bits. So if you apply your AND operation with your subnet mask and your IP address, you'll get out the network address. And you'll see on the bottom, I've got the network address there is a series of ones and zeros. It's in, decimal into binary, but then it's suddenly just all zeros. And that all zeros portion is the network or the host part of that address. So we can do this operation where on the left side, we take our local IP address, we apply the AND operation with our subnet mask, and we get out the network address. And then we do the same process for the other IP we want to check. We take the other IP, we apply an AND operation with our local subnet mask because we know that subnet mask. And then we get out the network address of the remote IP. And so we discover they have the same network address for both IP addresses. We know the host is local, so we're going to forward this packet locally from our MAC address directly to the destination's MAC address. And how that process happens is it's called ARP, but I'll cover that in a different topic. But we know it's local. If we do that same process where we have our address, we find out our network address, and then we get the network address of the other IP address, we discover that the two network addresses are different. We know it's remote, so we know we have to send that packet to our default gateway, or if we had other more specific routes in our route table, we could do that, but probably it's just going to go to the default gateway, and that router will take care of forwarding the packet towards its destination. So if we write out an IP address in this format, this is called the CIDR format. Instead of having a subnet mask, we just have an IP address, and then we put a slash and a number, and that number is the number of bits that are ones in our subnet mask. So a typical subnet mask, the 255, 255, 255 address, that is a /24 subnet mask. So that's the most common. Most IPv4 networks operate on a /24, but you'll see other numbers. It could be a 23, it could be a 16, it could be anything. It can be anywhere from, I guess 0 is technically not valid, but 1 I guess would be. All the way down to a /30 typically for point-to-point links between routers, or even a /31 on routers that actually support that. But based on this format, you can get information back out. So we can figure out what the subnet mask is in the format we're more used to it, because you can do the calculation to go from /24 over to the subnet mask. It's just binary, just write it out, 24 ones followed by 8 zeros. Convert that to decimal in 4 bytes, and you get this. We can also figure out the network prefix based on that, so we know that's the prefix or the network address for that IP. We know the broadcast address for v4, that's the host address where it's all ones. The network prefix, the host part's all zeros, broadcast is all ones. So we can figure out based on the information that we started with, what all those things are. And we can also get the usable host range. So in this example, it starts at .1 and goes all the way up to .254. The first host on my networks is usually the gateway. Some network administrators like to use .254 as the gateway, but you could pick anything. It's really confusing if you put it in the middle. And then in my department, we usually reserve the last 10 and the first 10 addresses for internal networking use, because we may have multiple routers running redundancy protocols or things like that, where we need multiple addresses to accomplish that. So we don't actually hand those addresses out to other people. So we'll reserve a block of addresses on each end for stuff like that. This same process also works for IPv6. So this is an IPv6 address, also in CIDR format. So we have that /64 at the end. /64 is the most common network subnet length for a particular network. But again, any number works. You can have anywhere from, you're not going to have anything lower than /32. I mean, that's like an ISP level allocation. But, /64 subnet's probably what you're going to run into. But it could be smaller. Some people will do point-to-points with like a /126 or 127. So you know, but the same math applies. You can always figure out these things. Now, there's not a subnet mask format for IPv6. We just give the prefix length. We always use CIDR format for IPv6. But you can figure out that prefix length and the network prefix based on that address. And then the usable host range is actually 2 bigger in IPv4. All zeros and all ones for the host part of the address are perfectly valid addresses. Because we always use CIDR format, the network prefix, we don't have to reserve that first address. So we can use it, and there's no broadcast in IPv6. It's all using multicast. So, but the same math applies. So I found this cool calculator that I use a lot. It's called the Tunnels Up website. They have a subnet calculator. It's a really useful tool. You can also follow me online if you want to see more content like this.